Engine Performance Expo here in Piney Flats, Tennessee, and they are excited to be here in person, as am I, for our first roundtable discussion. Going around the corner from my right, we got Ben Herheim. Of course, Billy Godbold making his first appearance so far. Climbed out from under the table after that whole FSU debacle. Sorry, Billy. Got to throw a shot. Got to do it. Of course, Pim Vandenberg, Chris Straub, and Lake Speed Jr. These are my favorite, the roundtables, because we get to see and hear what everybody's thinking about the direction of the industry, where things are, where they're going, what's happening, and what is hot.
I agree. I love the roundtables, and this one's is really key. Like, we're just showing the eye in the sky shot. We were saying, 4 years ago, we couldn't even have more than 7 people in the building at a time when we were doing it, because that was during the middle of COVID and everything. And man, things have changed a lot. I mean, so part supply, all kinds of effects that came from COVID really did impact our industry quite a bit. So I felt like it was appropriate to start off this year. And let's have a kind of recap. Where are we now? With everything that's changed in this world, what's the temperature?
On the retail side, we get a lot of guys that have been hot rodders for 30, 40 years and stuff, and they're asking, why can't I get this? Why can't I get that? I know one hot subject right now is flat tappet camshafts. You can't get flat tappet camshafts and stuff. So we're trying to explain to them, the cam grinders ordered on the tail end of the OE suppliers for decades. Mm-hmm. Well, GM, Ford, and Chrysler haven't made a flat tappet production engine in over 25 years. Well, when that market fades away, it's kind of like, some of us know what a rotary phone was, but when's the last time you saw a rotary phone? So Billy and I were talking the other day, and being where he's worked over the years and stuff, he's got a really good perspective on kind of how the industry's transitioned. So I'd like, Billy, just to tell the public out there kind of what's going on.
Well, yeah, Chris, you're right. When you set up for, I guess as long as I can remember, the F-150 was probably the biggest selling car in the U.S. And, they had, CWC, Textron was pouring all the cores for that. Even when they went into roller camshafts for GM, Chevy, with even Dodge, those were poured at CWC, the roller camshafts. That whole industry kind of got moved around to these assembled camshafts, different technology, and trying to get it's sort of like you build this aircraft carrier when you need a PT boat.
Right.
That we built this huge facility to serve cast iron, and now the market's tiny compared to what is. And we even talked about it, that you think that we'd get on the tail end of a pour for OE, but even things like the agriculture industry is much larger than performance. Even somebody making aircraft engines, that'd be larger than performance. So our industry is a spec.
Yes.
On a spec. And so that you take an industry that was built for hundreds of thousands, millions, and then you say, hey, I want 100 of these or 1,000 of these. How do you resize that same factory to do that? How do you build that business? I don't know, and I don't think anybody else really knows how to do it.
Well, and I think I was told at one time, we engine power components that grinds a lot of camshafts that would be buying cores from CWC, mm-hmm. and I don't think I'm misspoken on this, the performance industry represented less than 1% of their overall volume and stuff. So, and we have to look how things have changed. We have roller camshafts. No, it's steel cores. The other thing is the labor part of stuff type deal. You can't get people to work. Ben, you're at Andrews Camshafts and trying to get people to work. Chicago area, highly populated. What's it like to hire people to work in the plant these days?
Sounds like it's going to be, it is difficult. It's going to be more difficult. We run 2 shifts. Luckily, we have a bunch of really good, dedicated people that keep showing up, but every time that we want to add equipment, we have to find more people to staff said equipment. It's difficult.
Right.
So you buy robots.
Okay.
Yep.
And then, Pim, what are you all seeing? Another complaint's pistons. Why do my pistons taking so long? Why do my pistons cost so much? Type deal. You know, this is what the public.
Oh,
I mean,
you want to talk cost?
well, and they're on the internet saying, you know, there was a gentleman that just spoke the other day and posted, you know, 5 years ago I bought a set of forged pistons and they were $750 for my big block Chevrolet. Now they're $1,200. I mean, what are you all seeing in the piston?
Now, the cost of aluminum, for one, has changed, and the cost of forgings and the planning of forgings. For us, it's a real challenge to, okay, we're going to have stock bore on hand. We buy it in bar stock. We buy by diameter. If we get an order for, let's say, 4.5 inch, if we have the bar stock, great. If we don't, it's 6 to 8 months to make sure we schedule that ahead of time.
Now wait a minute, 6 to 8 months,
Yes.
not 6 to 8 weeks,
No.
6 to 8 days,
Our bar
months.
stock, we plan way
Months.
ahead, and the investment on that is quite substantial. So we have literally several $1 million of bar stock on hand to be able to satisfy a spec of a market that all of a sudden says, hey, this is no longer a hot size. We're going to go with this because this is way cooler and it works way better. Billy is one of them. He goes like, I want this.
Right.
Well, I don't have bar stock for that.
Especially if it's bigger, that's a problem.
Yeah, it gets to be a challenge. So you have to plan that. And then, well, we fortunately in Mexico, with our plant in Mexico that makes all our forgings, we have a very, very loyal crew, very dedicated and qualified people that have been working there in the plant for, many have 20 plus years. And so that part for us is not a problem. What is a problem for us is making sure that we get our smaller orders pushed through a manufacturing plant. The same issue you have is when you have a low volume item come through, it's disruptive. Mm-hmm. Yeah, I personally would love to make one piston, one size for everybody. It doesn't work that way, especially when you get into customs. But it is a bit the reality of the future. I mean, you see more and more people wanting specific things, specific designs, specific attributes on a piston. That now we just got an order in for a set of pistons that have a 0.6 piston ring, the top one. We don't
Real piston ring, by the way.
Yeah. And you make a good piston ring for it. My tooling, at the moment, the smallest ring I've cut so far is 0.7. Now I go to another. What's the end? And how do you cut that without crashing the tool? Mm-hmm. So we're in that challenge.
Yeah.
So
it's a big deal.
It is.
Yeah, and then how do you measure it? Because you've got to get a probe down in there that goes in.
And a lot of people, so here you have a good example where, why is my cost so high? Yeah? Things like that change. You think about the tooling, but you're absolutely right. Probing the equipment to measure what you just did.
Yes.
To make sure. Somebody said this morning there's not enough testing done in our industry. But our industry moves so fast. It is sometimes so difficult to actually test something that you build. So when it comes to customs, you're building a piston based on the communication between our engineering guys, Daniel Shearhold, Tom, and guys like Billy.
Right.
And it's a Lake, Nick Klunder. Those guys get together and they build for us, okay, this might work, or this is going to work. So it's really cool, but it's challenging, and yes, it'll impact the cost of the part, for sure.
And Billy, back to you on the camshaft stuff. In your previous life, you've been around cam grinding. Over the years, what was from going from flat tappets to roller camshafts? With the transition 20 years ago, how many flat tappets did you all grind at your previous employer compared to, when you stepped out on your own? And what was that?
We'll just give a back of an envelope. Say that if comp would grind 400 cams in a day, maybe it'd be 250, 150, or it'd be 200, something like that for a long time. The thing is that it's really hard. People don't realize how much of a system an engine is. Like we had some oil guys come to us and said, hey, we want you to make a flat tappet LS, and sure, okay, and they're like, well, how much is it? Well, it'll be $250,000. And they fall out of their chair, and you're like, Well, yeah, we've got to make patterns for it. Then we have to test with the offset. We have to do all this stuff, and you have to have enough to make. And in a year, you give us $250,000. A year from now, you'll have all this flat tap and do all this test. And they just like I said, they fall out of their chair. It's hard to change people got this idea that when I was, we'll take way back to when I was a 16-year-old Billy racing my Jeep, in mud drags. And I wanted to take my flat tappet cam out and put a solid roller camshaft in it. And I went to Bill Metzger at Laser Camshafts. Okay. And I'm like 16 years old. He's the only guy that'll talk to this crazy guy, because everybody else like, no, you're a kid. But it was going to be like $1,000 because I had to buy the billet camshaft, I had to buy the roller lifters, I had to buy different length push rods, I had to put new heads on it, studs on it, different roller rocker arms, different valve springs. I had to change the whole thing. So people got this idea that going from a flat tappet to a roller was this super expensive deal. Now, honestly, the valve spring and push rod and rocker arm, especially the valve spring and rocker arm, don't know whether it's a roller or a flat tappet. They just know how quickly you're moving the valve. So perhaps you could do a roller camshaft that uses some of the same pieces. So I don't know, and that's something we're going to have to be better at talking to our customers about. But changing technology over, the reason everybody just didn't go over to rollers is they were like, man, it's $1,000. I don't think it has to be. And then the whole thing to do a flat tappet right might be even more expensive, because my goodness, if you have to do a DLC lifter on a steel flat tappet camshaft, that's going to be more than $1,000. And man, and you talk to these people on the phone that do a flat tappet and have an infant failure, have one wipe a load. Well, that's going to happen a small percentage regardless. If you do everything right, you're going to have a certain failure rate with a flat tappet that there's not with a roller. And that when it fails, you need to take all the cam bearings out. You need to blow out all your oil passages and everything like that.
It's not a fun day.
If your time is worth a nickel, if you're a $5 an hour guy, you might put $1,000 worth of your time in pulling this motor out of the vehicle, tearing it down, cleaning everything out, putting new bearings, new gaskets, and putting it back together again from failing a camshaft as you would. Or do you just risk it and put another one in there, and maybe you got junk in your oil galleys and you kill another one,
Well, and that brings to the point, if you got Joe Sr. and Joe Jr. and they want to go circle track racing, okay? So they're on a budget. Both of them got decent jobs and stuff. But they're going to build their own engine and stuff, which, hey, that's what this industry is built on, building your own power. But if they're going in that class and that flat tappet fails and they're like, well, that was a fluke. Well, then they get another flat tappet and it fails. So now we're 2 in a row. I've got some customers that have failed in the same engine 3. How's that taste for Joe Jr. wanting to go racing with Dad? Dad, we haven't even gone racing. All we're doing is building this engine over and over and over again. So go, transitioning from that flat tappet to a roller, the benefits of that, Billy, for long term and stuff.
Well, you could imagine if you were an engineer at GM or Ford in the mid 80s, and you're buying a camshaft and lifters, let's say for $30, and that's being generous, being really generous. And you go up to your boss and say, hey, I want to put a roller lifter and a roller camshaft, steel roller cam and a roller hydraulic roller lifters. Now let's just say that it's $130. That's the other was cheaper than this, and going to the roller was more expensive than $130. But let's just say that. Now you do it over a couple 100,000 vehicles, and you're talking about millions of dollars they spent a year to go to roller camshafts. Why'd they do it? Well, to save money. Why'd they save money? Because they didn't have to worry about those failures. Because they're building hundreds of thousands. They statistically, whatever they did, they were going to have failures. I don't think people realize that when they're only building 1 or 2 or 10 engines, that there's going to be failures with flat tappets, no matter how good you are.
And they could reduce the amount of zinc and phosphorus
in
the oil.
That came about later.
They also let them have smaller catalysts. Well, platinum and palladium, that are the catalyst, is really expensive. So, and the total cost involved in the end, it was cheaper for them to do that in the grand scheme.
After they found out, because then all the controls, because fuel injection stuff, so much came around, they'd never go back.
No.
But it's interesting. You talked about the one guy with the block too. You know, one of the things that's interesting, working as a consultant, you know, I'm very good friends with Norris Marshall and the guys over at Blueprint Engines. And when they started to do their own blocks, that they were able to get index those lifter boards on their blocks, where you would get used blocks, seasons blocks, and these things will warp over time. And so you'll have a couple of blocks out there that, unless you send it somebody like Keith Dorton, have him put new lifter boards in it, you know, somebody to index that lifter board, you know, you can wind up with a block that's going to eat every camshaft that goes in there.
Well, in your past history too, I remember years ago I said, well, what about zinc? And then you said, well, which formula of zinc, Chris? I think a lot of these people just think, oh, I'm just going to stick some additive in when I do this. Can you touch a little bit, because you've always said it really needs to be done at the refinery to get all of those anti-wear and stuff. Touch on that with the flat tappet stuff.
So there's two things. Back to Billy's point and Marshall's experience, is that no amount of zinc can fix bad geometry.
100%.
It will fail. I don't care what you put in there. You know. The second part is, there are more than one type of ZDP. So zinc's not just one thing; it's a family, and it's actually part of the blend process. And that if people that just go buy an engine and they get that bottle of ZDP and they just pour it in the valve cover and they fire it up, well, where's all that stuff? It's still a valve cover. It's not mixed in the oil. It's not in the camshaft. And as we both know from doing flat tappet spintron testing, that thing, even though it may not audibly make noise that it's dead until 20, 30 minutes later, it will live or die in the first 2 minutes.
Yeah. And the people don't understand, when you're trying to brew your own home chemistry, that there's only so much surface finish, and every additive in there is trying to grab hold of the surface.
Yes.
So all of a sudden your detergents that are really important, you know, if you can go a while between oil changes, they're grabbing hold of that surface and they're getting in the way of the zinc. So you really want a break-in oil that was formulated to let the zinc do its job.
Yeah. That is the truth.
Can I jump in with a question, as you know, I'll call myself a novice. And seeing some of the questions out there as well, there are some series that by rule use the flat tappet cam as what at the time was a restrictive, cost restrictive measure. Should we encourage them to move beyond those rules? Should we say, hey guys, stop with the flat tappet cam, it's counterproductive now, and it's time to just, I hate to say this word, but kill that old technology and move forward with this newer, now cheaper, easier, non-disruptive, more reliable technology of a roller cam, and stop with the flat tappet cam? Should we do that here today?
So Joe, to your point, because Ben and I have been working on this for about the last 18 months and stuff, we actually have a flat tappet series that we've been working with one of the founders. Ben developed the lobes to match the flat tappet lobes. We actually did 3 camshafts. We did a camshaft that we knew would work, a camshaft that would push the limits, and a camshaft that would absolutely destroy the valve train. And Ben, after the results with Ben's lobes, we were within 4 horsepower of duplicating that power. But Ben, I'll let you touch on that as far as core availability and that type stuff.
Well, as far as the flat tappet cores go, what I have in inventory right now at our facility is less than 2 dozen. So what Chris and I devised, his idea, was to
your talent
mimic the the same motion that the flat tappet cam had in this particular series. This series has a valve spring rule, so we were utilizing the crummy little spring that was made for the flat tappet with a roller cam. We were able to do near same motion. Roller lifter really wasn't much heavier than that flat tappet lifter, was it, Chris?
And it was a solid roller profile.
Solid roller profile. Yep. And it seems like it was pretty successful. The gentleman that tested it sure seemed excited when he called.
So now we've got something that may last 5, 6, 7, 8 years, and Joe Senior and Joe Junior can go. They don't have to replace push rods, don't have to replace valve springs, nothing.
And like I started with, they doesn't really need a different valve spring. It doesn't need a different rod. It doesn't need.
Yes.
It doesn't need that $1,000 that Bill Metzger was telling me to spend.
Right.
It just changes cam and lifter, and then get rid of that headache.
Yeah.
So a signal to the rules makers out there to be helpful with this. Right now, people are struggling to keep up with those rules packages because they're, call it impractical. So maybe update the rule books in the near future as best as is possible.
Well, I think this is one example of a bigger picture where as technology continues to evolve, and I mean technology, I mean what the OEs are doing, back to the very beginning of the conversation, that our industry rides the coattails of what the OEs have been doing, right? That it's always been them that has been pushing forward, and then we kind of come in afterwards. As they push into new areas, be it full hybrid or full electric, hybrid, whatever else that comes along the line, we as an industry will have to respond because our venerable old small blocks aren't going to be around anymore. And it's probably impractical just to rely on our manufacturers to be able to do everything at the cost they were before. Because now, if you still want that one, you can still get it, but now you're talking about maybe very small production, costs go way up. So to get the bang for the buck, we're going to have to think outside the box, and rules makers and people are going to think differently going forward. I can't see any other way of it being.
Excellent. Well, I think we have covered a lot of ground here in this first roundtable of Engine Performance Expo 2024. And I know that this group has the power to enact change out there, as there's a lot of there are people that watch this and they take this into consideration as they work on 2025 and beyond. Excellent work.
Thank you, sir.
Yeah.
Well, and what's coming up next is Jeremy Wagler, diesel guy, right? So we're talking about gasoline stuff. Well, they're facing a lot of these same things. There's a lot of change and evolution in the diesel market. So Jeremy is going to give us a little bit of talk about how that is going and how they approach it.
What a day, what a day, what a day. My brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.